Hey there everyone. There is only one thing left from the chapter of straight lines, which is the topic is parallel lines. Now then, let us see what I mean by parallel lines. Basically, any two lines that are parallel to each other. What are parallel lines? Lines that do not touch each other, that never intersect with each other and are together. What do I mean by that? See, these lines are exactly the same. They have the same direction. Any two lines that have the same direction but do not intersect with each other are called parallel lines. So then, what is so special about parallel lines? Basically, if I call this line A and B, this is known as line AB, and this is known as line CT. So then, what is special about this? Basically, parallel lines have the same gradient. So then, for example, the so the gradient of line AB, I can write this m of AB is equals to the gradient of line CD. So I can write this m of CD. This says that the gradient of m of AB is equals to the gradient MCD. See, it's pretty simple. This all you have to remember is this, that two parallel lines have the same gradient. Now then, what is the shoeless formula? Shoeless formula is a formula used to find the area of any object whose coordinates are known. So then, let us draw a small object whose coordinates we can find, whose coordinates we have been given. Now then, here is a shape which has 5 sides. A, let's call it x1 and y1. B, let's call it x2 and y2. C, let's call it x3 and y3. D, let's call it x4 and y4. And lastly, E, let's call it x5 and y5. Now then, how are we supposed to find the area of such an object whose formula of area we do not know? So then, we use a formula called shoeless formula. Know this, that in this formula, we go anti-clockwise. For example, if we start from A, we will return to A. What do I mean by that? Let's see. A for area is equals to 1 over 2. Now then, we draw this straight line. What is a straight line? It is known as modulus. What is modulus? Basically, if you put any number as modulus, it comes out as positive even if it is a negative number. So then, if I plug in -3 in a modulus, it will give me a positive 3. If I add a 3 in modulus, it will give me a positive 3. So this is the job of these two lines. That means that the answer between this, if it is negative, it will convert the answer into a positive one. So then, how do we do it? We begin from A. We write the coordinates of A, x1, y1. Then we write the coordinates of B, x2, y2. Then we write the coordinates of C, x3, y3. Then we write the coordinates of D, x4, y4. Then we write the coordinates of E, x5 and y5. And as I said, we start from A and then we return to A. We start from A and then we return to A. Thus, the coordinates of A will be written again, x1 and y1, and lastly the sign of modulus. Now then, how do we resolve this? We multiply all of these with the cross. What do I mean by that? Basically, anything that is like this. For example, diagonally of x1 is y2. So we say x1 multiplied by y2. x2 y3 is diagonal to x2. So we multiply this. 2x3 y4 is diagonal, so we multiply this. 2x4 y5 is diagonal, so we multiply this, and 2x5 y1 is diagonal. Now then, that this is done, we multiply the one's diagonal to y. 2y1 x2 is diagonal, so we say y1 into x2. 2y2 is x3, 2y3 is x4, 2y4 is x5, and 2y5 is x1. Now then, we are going to multiply these. So then 1 over 2. Firstly, I am going to resolve the green ones. So this comes as x1 y2, and then we, by the way, we add all the green ones together. x1 y2 plus x2 y3 plus x3 y4 plus x4 y5 plus x5 y1. Now then, we make a bracket between them, and now from this we are going to subtract the red ones. Minus, because I don't have space, I'll write it below, y1 x2 plus y2 x3 plus y3 x4 plus y4 x5 plus y5 x1. So then the answer of an area can be formed from this formula, also known as the shoeless formula. Now then, that we are done with the lecture of coordinate geometry, it is time to start some questions. On the screen is currently a question from the year 2019, month May-June, paper 11, question 4. So then, let us see what this question is asking us. The diagram shows a trapezium ABCD. As you can see, there is a trapezium ABCD which has coordinates A, B, C. The coordinates of A are 4, 0, the coordinates of B are 0, 2, and the coordinates of C are h, 3, h. The lines BC and AD are parallel. The lines BC and AD are parallel. So then, what does this mean? As we just learned a few moments ago, that two parallel lines always have the same gradient. So I can say M of BC is equals to M of AD. See, the gradient of BC, the line BC, is same as the gradient of AD. We just learned this a while ago, that parallel lines have the same gradient. And now it is saying that the angle ABC is 90. As you can see, the angle ABC is 90. As we have learned before, the two perpendicular lines always make an angle of 90. So, as there is an angle of 90 between the line AB and between the line BC here. See, this is the line AB, this is the line CB, and there is an angle of 90 degrees between them both. This means that these two lines are perpendicular with each other. So what can be determined from this is we can determine that M of AB into M of BC is equals to minus 1. Basically, they are negative inverse of each other, as we have learned before. So then, what else does the question say? It says CD is parallel to x-axis. As I have told you before, that any straight line which is parallel to the x-axis will always have a gradient of 0. So we can say that the line CD has a gradient which is 0. Okay, now then, let us move on to the first part of the question. Find by calculation the value of h. It is asking us to find the value of h at the coordinate of C. So then, what can we do to find h? We can use this. Why am I saying we can use this? Because as we can see, we have both the coordinates of the line AB. of this line, we have two coordinates, or this means that we can find the gradient of AB. So if I can find the gradient of AB, can I not find the gradient of BC? Okay, let's just do this first. The gradient of AB is equals to y2 minus y1 over x2 minus x1. So what is y2? I'll take this as x2 y2 and this as x1 y1. So then y2 is 2, y1 is 0, x2 is 0, x1 is 4. This comes out as 2 over minus 4. This becomes minus 1 over 2. Now then, we can use the formula MAB into MBC is equals to minus 1. We can replace MAB with minus 1 over 2 as we just found out. Now then, this 2 can be moved there. This becomes minus 2 and this one comes below. So this becomes M of BC is equals to 2. Now then, we know the gradient of this line BC. We just need to find out these coordinates. So then let's just use the gradient we just found out. So we can say M of BC is equals to y2 minus y1 over x2 minus x1. Now then, we can replace M of BC with 2. And what shall we do with y2 and y1? Let's make this as x1 y1 and this as x2 y2. Okay, this was for before, this is for now. Okay, we just use these, so this is no longer x2 y2, this is x1 and y1. So then let's continue. y2 is 3h minus, what is y1? y1 is 2. x2 is h and x1 is 0. So h minus 0. Now then, 2 is equals to 3h minus 2 over h. This h can be moved here. So then this becomes as 2h equals to 3h minus 2. This 2 can be moved there. 2 is equals to 3h and this 2 becomes here, it becomes minus 2h. So this becomes as h equals to 2. There is our answer. Pretty simple. Now then, to find the coordinates of D, how about I replace h with the actual coordinates? So then C now becomes h we just found is 2, 3h becomes 6 as 3 into 2 is 6. Now then, it wants us to find the coordinates of D. Now there is one thing to note, that this whole line, it has a y coordinate of what? 6, because it is a straight line, it is not moving down. So any point on this line will always have a coordinate of 6. So we can infer that the y coordinate of D is 6. Now we just need to find the x coordinate. So how do we find the x coordinate? What we can do is now utilize another thing that we found before, which is the parallel gradient. M of BC is equals to M of AD. Let's do this beside it. We know that the gradient of BC, which is 2, the gradient of BC is 2. So I'll just make this as 2, and we don't know the gradient of AD. We do not know the gradient of AD. So we'll just plug in the formula in its place. We'll say y2 minus y1 over x2 minus x1. So then, what is y2 here? We can just say that this is x1 y1 and this is x2 y2. So 2 is equals to y2 is 6, y1 is 0, x2 is x, x1 is 4. So this becomes 2 equals to 6 over x minus 4. We can bring this x minus 4 here and 2 here. So x minus 4 is equals to 6 over 2. This becomes x minus 4 equals to 3. X is equals to 3 plus 4. Therefore, x is equals to 7. So the coordinates of D are 7 and 6. Now then, here we have another question. It says 2 points A and B have coordinates 1, 3, 9, 1, 9 minus 1. Basically, there are 2 points that has coordinates 1, 3 and 9 minus 1. A has the coordinates 1, 3 and B has the coordinates 9 minus 1. They always give coordinates in the order that they have mentioned. Now it says the perpendicular bisector of AB intersects y-axis at the point C. Now then, there are a few things to notice here. It says perpendicular bisector. What does this term means? Basically, it means that we have two lines. Let me draw them. There is line 1 and now there is line 2. Perpendicular bisector. What does this mean? It means that first of all, there are two lines which are perpendicular to each other. The bisector word means that the two lines which are perpendicular to each other are bisecting each other from the middle. So what does this mean? You can say that there is a line 1 and there is a line 2. This line 2 will intersect, or you can say this line 2 will cut line 1 at the midpoint of line 1. So line 2 will cut the line 1 at the midpoint of line 1. This is where this line will be perpendicular to line 1. Line 2 is perpendicular to line 1 at the midpoint of line 1. That is what perpendicular bisector means. So what does the question here says? The question says the perpendicular bisector of the line AB intersects the y-axis at point C. So basically, if we were to plot the coordinates of what they have told us, it would look something like this. Here, let us plot the coordinates. Let's say B is here. There is 1 for the x-axis and this is the y-axis, and then let's say 3 is here. So this is B, point B, and this point A. My bad, I'm so sorry. This is point A. Now for point B, the coordinates of B are 9 and minus 1. So it will be somewhere here. Let us draw a line AB. Okay, now that we have a line, it is telling us that there is a perpendicular bisector to line A. Basically, it is saying that there is a line that is intersecting AB at the middle point, and that line which is intersecting AB at the middle point is cutting the y-axis at a point C. Let me draw it for you. So let us draw a line like this. See, this line is cutting AB in the middle, thus fulfilling the condition of it being a perpendicular bisector. And now it is also cutting the y-axis at one point, so this point can be called as C. It is asking us to find the coordinates of C. So then, how do we find such coordinates? As we have known that to find any coordinates on a line, we need to first know its equation. Or if you didn't know, then from now onwards, do know that if you need to find any coordinates on a line, you need to know its equation. So what we can do is find the equation of the perpendicular bisected line. How can we do that? We need two things to find the equation of a line. What is the normal equation of a line? It is y equals to mx plus c. We need to find the m and the c. M is the gradient, and what is c? C is basically what we are finding. C is the point where x is 0. It is the y-intercept of the line. So basically, if we find c, we will also find the coordinate c. Notice that this is not the coordinate c, this is the y-intercept c. Always remember this, that this and this are same, but this c does not mean the coordinate c. This just means the place where the line is cutting the y-axis. Okay, so then how do we find it? We need to know at least one coordinate of the line so that we can find its equation. We can do that by finding the midpoint of AB, because midpoint of AB is also in a sense a coordinate which lies on the point on the line which is cutting AB. Okay, basically the coordinate of midpoints are the coordinates of this line as well. So then let's find the midpoint. Why are we finding the midpoint? Because it told us that the perpendicular bisector it is. So then let's find the midpoint. As we remember that midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. We have all of it. The coordinates of A are 1, 3. Coordinates of B are -1, 9. See here. Oh, 9 minus 1. My bad. I'm so sorry. It is 9 minus 1. Let's find the midpoint. M is equals to x1 1 plus x2 9 over 2, y1 3, y2 is -1 over 2. M is equals to 10 over 2. 3 minus 1 is 2, which is 2 over 2. So the midpoint becomes M is equals to 5, 2 5 to 10, 2 over 2 is 1. So this becomes 5, 1. The coordinates of the midpoint are 5 and 1. Now we know the coordinates of the midpoint. Now another thing we need to do is find the gradient of this line, because look, to find the equation of a line we always need to know its coordinates and its m value, and from that we find the c. So then we have right now y and x. Now we need m so that we can find c. So how do we find m? Normally to find the gradient we need two coordinates of a line, but this time we do not have two coordinates, we only have one coordinate. So how do we find it? We can use another formula which we already did in the previous question, which is m1 m2 equals to -1. This is always used whenever a line is perpendicular. So what we can do is find the gradient of AB, and then we can find the gradient of this perpendicular line, whose coordinate I can say as m2. So then I can just say m1, the gradient of AB, is y2 minus y1 over x2 minus x1. So then we can say y2 is -1, y1 is -3, over x2 is 9 and x1 is 1. So this becomes -4 over 8, which is equals to -1 over 2. Now I can just plug it in this formula to find the m2. -1 over 2, m2 is equals to -1. Thus m2 becomes 2. We just did that above, so I'm not going to do the same thing again. Now we have a single coordinate and the gradient of the line. of the perpendicular bisector line. Now we can use this to find the equation of the line. So y is equals to mx plus c. Instead of y, I can write 1. In place of m, I can write 2. In place of x, I can write 5, and this is c. So 1 is equals to 10 plus c. C is equals to 1 minus 10. Thus, c is equals to minus 9. So we can write y equals to 2x minus 9. But we don't need to do anything further because this minus 9, as we know it, is the coordinate of this point. Y-intercept is the place where x is 0. So we already know the answer, which is c is 0 minus 9. This is how we found the c coordinates.